All right, we have a participant this morning. This is the Math 1113 Zoom meeting,
Yes.
November 6th. We have a participant. Do you want to identify yourself?
Yeah, this is Kenny Pinedo.
Okay, very good. I can barely hear you.
How about now? Is that better?
Let me see if I can turn up my volume. You got any questions this morning?
Yeah, I'm trying to pull them up right now.
Okay. All right, I think maybe I can hear you a little better now. What? Go ahead.
Can you hear me now?
Yeah, I can hear you.
All right. I'm pulling up the question right now. Um, First question I got here is a table question.
Okay.
And it's asking to complete the table,
All right.
but it's saying f of x equals 6 parentheses x minus 3 close parentheses, and then we're gonna put that to the power of 2. And the x's that's giving is -1, 0, and then 1, 2, 3.
What section is this off of? This isn't 7.2. Is this back from
Oh, I don't
class?
know why this took me to 2.1 instead of 7.2. I don't know why. I'm sorry about that.
No, no problem.
It's weird.
Do you actually want something from 7.2?
Yeah.
Okay.
Here we go. Here we go. It says use an addition or subtraction formula to write the expression as a trigonometric function.
Okay. Is this off
And
WebAssign?
yeah, this is
Okay.
the personal plan study one. And this one says tan of 79 degrees.
Oh, tangent
Yeah.
of 79 degrees. Okay.
Minus tan of 19 degrees.
Okay.
And that's all going to be over 1 plus tangent of 79
Okay.
times tangent of 19.
You want this written as a formula.
Yeah.
All right. So the trick is to match this to page 581. I put both of them on the screen here. So you can see it kind of matches this very bottom formula here, right?
Yeah.
Tangent something minus tangent something. So this is like your S and this is like your T over 1 plus tangent S tangent T. So you see your S is 79 degrees.
Yeah.
Your T is 19 degrees. Both on the screen, barely. So you see this is going to be equal to tangent of S minus T. I'll use S's and T's first, and then that would be tangent. S is the 79 degrees and T is the 19 degrees. You're kind of using the formula backwards.
Well, it's kind of like plugging in. You're not really doing too much like math.
Yeah, it's not much plugged in. They gave you this whole right side, and you just got to plug in on the left side, which is a lot simpler.
Okay.
Well, then it's just a matter of simplifying. You're getting a tangent 60 degrees, and that's off a circle. I believe that's going to be √3. If you look at 60 degrees, your y is √3 over 2, and your left's a half, or your x is a half at 60 degrees. So your tangent 60 degrees is going to be √3 over 2 over 1/2. Take your top times the flip of the bottom. Yeah, you're going to get √3. So this simplifies to √3. whole answer up here is root 3. Did that help or did that go too quick?
Oh no, it kind of it clarified a lot for me because I wasn't really understanding what to do at the beginning.
Yeah, all of this section is pretty much all about messing with these formulas in some way or another, the identities, verifying those identities and everything, all pretty much reach back to these formulas.
Um this one says prove the co-function identity using the addition and subtraction formulas.
All right.
And the formula it gives me here is secant of pi over 2
Okay.
minus u parentheses
Okay.
equals cosecant of u.
All righty.
And then it says here to use a reciprocal identity, then apply a subtraction formula to simplify.
Right. I know that reads like gibberish. They think
Yeah.
they're being helpful, but all they really mean, again, is to reach back to these formulas. All right. But again, the only formulas are given in terms of sine, cosine, and tangent. So that's when you got to reach back and realize a secant is 1 over a cosine. So that would be 1 over a cosine pi over 2 minus u. Cosecant u. And cosine of something minus something, that's going to reach to this fourth one, where the s is going to be pi over t and the t is going to be u. Can I just plug and chug in terms of pi over t and u, or do you want me to write it down in terms of s's and t's?
Whichever one's easier for you, to be honest. I'll probably understand either way.
Okay. So that's going to be 1 over, see, this is going to be like your s. This is going to be like your t. So a cosine of these things goes cosine of both. And then you do an opposite sign and sine of both. Cosecant of u. So that is your cosine s, cosine t, plus sine s, sine of t. That's what they're doing here. Cosine s, cosine t, opposite sign, sine s, sine t. Are we ready to plug in the numbers?
Yeah.
Cosine of pi over 2, if you, again, you reach back to the circle. Pi over 2, you're up at 90 degrees on the y-axis. Your coordinate is 0, 1. Cosine is directly 0, sine is directly 1. So this cosine of pi over 2, you're getting 1 over cosine of pi over 2 is 0 times cosine u. Sine of pi over 2 is 1 times sine u. So you can see this vanishes. You're getting 1 over a sine u. This is going away. And that is equal to a cosecant u. You want to go on one more step, say this is cosecant u equals cosecant u. That's about all there is to verifying it. That okay, or did that go too fast?
Nah, you're good. I'm just trying to make sure I get this last bit of it down.
Like I say, on the test, if I had this on the test, I would have either decided to do it correctly or screw it up some way. And then you would look through and decide, did I do it correctly? In which case you put down true, or did I screw it? Did you spot my mistake? And then you put down false.
this next one says write the given expression in terms of x and y only.
Okay.
And the expression is cosine of sine. Oh, I'm sorry, cosine of the inverse of sine
Okay.
to x minus the inverse of tan to y.
Oh, I bet it's all in one parenthesis, so I shouldn't have a parentheses there, right?
No, there's a parentheses around the y and then around the x.
Does it look like this
Um,
with a set of parentheses there and a set of parentheses there?
yeah,
Okay. So you see, this is like your S and this is like your T. So this is like your S minus your T.
yeah.
So again, reaching back to page 581, that goes cosine of arcsine of X. That was cosine of both first. Cosine of arctangent Y. Then you do an opposite sine and sine of both. Sine of arctangent Y. Okay, so that's pretty much straight plug into chug into a cosine of S minus T. Or again, this is S, this is T, this is S, this is T. Is that as clear as Lake Lanier?
Yeah.
You just got to remember, arc things are angles. So they're just treated like any other angle. Now, I think of this as four separate pieces. When your function here don't match, you're going to have to work out with a triangle. But one piece here does match, piece three, the sine of arcsine.
Yeah.
I could use a triangle if I wanted, but it's kind of way overdone. You can just, that should be obvious. Those two cancel, you get X on piece three here. But if you want to number these, piece one, piece two, piece three there we've done, and piece four. So I'm going to need two triangles, one for piece one here. So you want to label this piece one triangle. Stick this over one. When you work out a triangle for it, sine goes opposite over hypotenuse. And then you need to see all the algebra out to work out this leg, or can you tell it's square root of 1 minus x squared, or does that need explanation?
Nah, this doesn't need explanation.
Okay. So see, now I can work out the cos. See, this angle is arcsine x. And now I can work out the cosine of it, which is adjacent over hypotenuse. 1 minus x squared over 1, if you want to see all the pieces, which is just square root of 1 minus x squared. I could show you how piece 3 works out off the same triangle, but in fact, you can almost see it here. The sine on this is x over 1, which is just x. All right, so I've worked out piece 1 and I've worked out piece 3. Are you ready for piece 2 and piece 4?
Yeah.
Okay. Now, since those are the same angle, I only need one triangle. We can call this piece 2 and piece 4 triangle. Triangle. And so again, that's over 1, y over 1. So y over 1, it's a tangent. So that's y1. So opposite over adjacent. And can you tell hypotenuse you're going to right at 1 plus y squared. Is that too fast? You're going to square this, add them up, and take the square root.
Yeah.
Okay. So for piece 2, all you need is a cosine. Well, that would be adjacent over hypotenuse. That's 1 over the square root of 1 plus y squared. And for piece 4, you need a sine. So the sine is equal to opposite over hypotenuse. Are we ready to, this was piece 1. Are we ready to plug and chug these pieces into this?
Yeah.
Okay. So piece 1, square root 1 minus x squared. Piece 2 times 1 over square root 1 plus y squared. Add piece 3 was just x. And piece 4 is y over the square root of 1 plus y squared. Now, it's a perfectly fine answer, but the book will probably clean it up just a little bit. It's really all just plug and chug, but I realize it does lead to a whole page full of gibberish.
Yes. I mean, a little bit. Just
Okay. Now, they've got a common denominator here already, so you can write it as one fraction with a square root of 1 plus y squared. And on top, you'll have the square root of 1 minus x squared. You're going to add xy. That's probably what's, well, it's not in the book, it's from WebAssign. But if you can manage to enter that in WebAssign, it's not an easy entry.
wait. So the that's like the final answer right there in the bottom.
Yep. You could give me an x and a y to look the only other way to convince you maybe is give me an x and a y. They'd have to be in the, I don't know, I might be breaking up here. Unstable. Okay, can you hear me back again?
Yeah. I couldn't hear you for a moment there.
Yeah, I went unstable. If you give me an x and a y in the domains, correct domains up here, we could literally punch it like this. And then we could come down, stick the same x and y into this and punch it like this. And you'll get the same answers. You want to take the next 10 minutes and see it done, or do we believe?
I'm sorry, it cut off again. I couldn't hear you.
Okay, did you hear me about, I'm trying to, if you give me an x and a y, you can punch it literally on the calculator, uses these labels. So you can punch it like this. And then you can punch the same x and y in this and you get the same answer. Do you want to see it done, or do we believe?
I'll see it done because it kind of looks interesting.
Okay, well, you want to give me an x and a y. Your x is going to have to be between -1 and 1. And I'm trying to think back, domain of arc sine is the range of sine, which is -1 to 1. Yeah, the x has got to be between -1 and 1. Your arc tangent, I don't think there's any restriction on y. The domain of arc tangent is the range of tan. Yeah, it's -infinity. Yeah. You remember back to those domains and ranges? In other words, you can't just stick tan into an arc sine.
Yeah.
You want to give me some numbers? X has got between.
How about 1 and 4?
And y is 4.
Yeah.
Okay. X equals 1, y equals 4. We punch cosine of arc sine of 1 and minus arc tangent of 4. You want to be in radian mode. That's the beauty of these calculators. since they were invented, they used the labels you're used to. Cosine, arc sine of 1, whereas for hundreds of years, people had to use formulas like we just
Oh,
derived to work them out. Minus arc tangent of 4. Cosine of arc sine of 1 minus arc tangent of 4. 9701. Oh, I never checked radian mode. Yes, I am in radian mode. Okay, good. Got lucky. So yeah, that's the beauty of these calculators. You can use the direct math labels. Whereas for hundreds of years, people had to punch it with the formula at the bottom of the page. I'm going to sub in x equals 1 or into 1 minus x squared plus xy over the square root of 1 plus y squared. Give me the square root of 1 minus 1 squared, plus 1 times 4 all over the square root of 1 plus 4 squared. It won't be too bad because your square root here went to 0. So I'm going to wind up with 4 over basically the square root of 17. That 4, this is 0. 16 there plus 1 is 17. All right, if you want to give us a drum roll, we don't get 0.9701 out of this 4 over the square root of 17, I'll quit on the spot. Square root of 17. There you are. I don't know if that proved anything to you or only to me.
yeah.
All right. Do you have another one?
I think I got like 2 more.
Okay.
This one here says evaluate the expression under given conditions.
All right.
And it says sine of beta plus, and this one looks like a P with like a curl at the back of it. It's like
Okay.
a Q and a P mixed together. I don't know what that's called.
Like something like this.
It's hanging off the um I can share my screen if you want. I don't really know what this.
Okay. Yeah. Why don't you?
Is it showing?
Uh, yeah. You've zoomed into a little too far. Unless, yeah, if you could back out. Is it number 7?
Yeah.
Oh, okay. Yeah. Okay. Number 7 here is off WebAssign. Okay. That's called a phi. It's a circle with a line through it. That's a letter phi, and it's all in parentheses. Okay. Sine theta is equal to 5 over 13. Oops, you
Oh,
lost it.
right. Lost it right there.
No problem. I think I can get it from here if you want to read it. Well, no, I'm back. Okay. Theta quadrant 1.
There's a lot to read there.
Yeah, it's a lot of info to, and then that cosine of phi is a negative 2 root 5 over 5, and you're in quadrant 2.
Yeah.
Okay. Let's see if I can get back to my camera. May have to resume the share. Yeah. Take me just a second to start the share again.
No problem.
Okay. Oh boy. Okay, there we go. It really, it reads really complicated, I understand, but it really is nothing but plug and chug. All of a sudden I've gone blank. Okay, let me try again. There we are. Okay, it really is nothing but plug and chug into this. So you need from page 581, write out what this is. And again, they're using these symbols. So this is like your S and this is your T. So do I need to show you that formula on page 581?
The addition and subtraction one.
Yeah, it's the very first one.
All right.
So you see how that one goes as sine times cosine, same SIGN in the middle, and then reverses cosine sine. So
Will it be like word for word like that when you're like looking at your assignment and looking back into the book when trying to find it?
yeah, we got to hug these formulas. If I give you a problem, it's got to hug these formulas.
Yeah.
And I can't keep you from using the book like I could in the regular class online, you know? So yeah.
Yeah.
So it goes sine of the first, cosine of the second, same sign in the middle, and reverses cosine of the first, sine of the second. Again, if you want to label this piece 1, piece 2, piece 3, piece 4. So the trick is to draw out triangle. I call it the theta. You'll need a theta triangle labeled with this in quadrant 1, and you'll need a phi triangle labeled with this in quadrant 2. And then the trick is to work around the triangles and see what you need to fill in, write the pieces down, and eventually plug and chug them in. So a theta triangle is quadrant 1. And the purpose of those quadrants is because that can change the signs of things. I draw a triangle into quadrant 1, label that theta. Sine means opposite over hypotenuse. And you'll want this leg, you need to see the arithmetic to get this leg. Call it x. X squared plus 5 squared would equal 13 squared. X squared plus 25 will equal 169. X squared would equal 144. And you see x square root, that'll be a 12. And it's going to be positive quadrant 1. That's where you pay attention to what these quadrants are, and you have to use positives or negative. I bet something's going to turn up negative being in quadrant 2.
Yeah.
The other one, but this one's pretty straightforward since it's quadrant 1. X and Y are both positive in quadrant 1. All right, let me go ahead and fill in the pieces here. You're going to need, this is the theta triangle. Why am I calling it? They switched symbols. Did I read that right? They said sine theta.
Yeah.
But they gave you this, right?
Yeah.
Yeah, they screwed that up. This is beta.
Oh yeah, because
Yeah.
yeah.
Sorry about that. I just caught that. This is beta. Actually, beta. Yeah, they screwed that up. There's no theta at all in this.
Yeah, it's weird.
Yeah, that's weird. Yeah. All right. So what you're going to need is you're going to need pieces.
No, sorry. For sine, it says beta plus theta. It's supposed to be a theta instead of b.
It was a beta plus, but I read this symbol.
Let me.
Yeah. Oh, oh, they put a theta. I'm sorry, it's a theta plus that phi.
Yeah.
So this should be a theta. Oh, now we've got it all screwed up if anybody's watching this.
Oh, will
No,
that mess it up in the long run?
no, we'll get it. We'll finally get the symbols right here, but that it's a theta there plus phi. Okay, I'll get back to my camera.
All right.
All right, I see what's going on. Okay, let's see. This is really not that hard. I don't know why it takes 20 minutes to explain it.
Yeah.
I guess just because there was confusion over the symbols. Okay, let me see. Okay. Okay. All right, so I've kind of overwritten them. So this was a theta, then these are thetas, and then this is a theta. Okay, so you're going to need piece that, so that makes this a theta, and this a theta. Okay, so you're going to need piece 1 and piece 3 here. Now they already gave you piece 1. In effect, they gave you piece 1 is 5/13. You can see that. So piece 1 sine theta is 5/13. That was given, and you need piece 3 cosine of theta. And so that, I'm off the page, 12/13, 12/13. So if you want to fill those pieces in, you have piece 1, 5/13, which was given. You really didn't need the triangle. And then plus, and piece 3 is 12/13. Have we gotten that far now?
Yeah.
All right, so to get piece 2, piece 4, we're going to have to draw this triangle out. And that's quadrant 2. So you got to really pay attention to that. Call it, come down here a little further. The phi triangle. That's quadrant 2. And this is phi, or this is phi. Call that phi if you want. Okay. The cosine is adjacent, you see, so that actually is going to be the negative root 2 root 5, and the hypotenuse is 5. All right, I'm probably cutting out because I'm unstable. Okay, am I back?
No, I can say.
Oh, you're here. Okay. So you see how I've labeled this
Yeah.
triangle adjacent over hypotenuse. Quadrant 2. This leg, we'll call it y. Figure it out, y squared plus my negative 2 square root of 5 squared equals 5 squared. Y squared plus, see, negative 2 squared is 4, root 5 squared is 5, equals 25. Are we losing you? Or
No, we got it.
okay. So y squared plus 20 equals 25. Y squared then would equal 5 because subtract 20 over. You're going to need a square root of 5. And again, it's positive because it's quadrant 2. So that's going to be a positive square root of 5. All right, well, once again, piece 2 is a cosine. Well, that was directly given. So that's going to be a -2 square root of 5 over 5. And your sine down here for piece 4, sine will equal √5 over 5, opposite over hypotenuse. Piece 4 here will be √5 over 5. So I have finally filled in all the pieces.
But what would be considered where it says like evaluate expression under given conditions? Like, what is that asking for at the
That's
end?
asking for its final result, and they probably want this simplified.
Oh, okay.
So I could cancel the 5s, but it throws me off a common denominator. See, I've got a common denominator of 65. I might want to leave that. Looks like I'm getting a -10 √5 over 65. Add 12 √5 over 65. A -10 √5, add 12 √5, that would be a +2 √5. Those are like terms, they've got the like root.
Yeah.
That would be 2 √5 over 65. And since 2 doesn't cancel into 65, that's pretty much as far as you can go with it. That should be the answer. If they want an exact answer, that should be it.
I think I got like 2 questions here left. That's all. This one says find the exact value of the expression. And this one is sine of the inverse of cosine
Okay.
of 1/2 plus inverse of tan of
Plus
1.
inverse of tan of 1.
Yeah.
Okay, so once again, this is going to look like S plus T sine. So that's again off page 581.
The subtraction and addition.
Formulas, yeah. If you written down S and T's, that would be a sine S cosine T plus cosine S sine T. Sine of these things goes sine times cosine plus cosine times sine, and you keep the same sign in the middle. All right, so filling this in, that's going to equal sine of arc cosine of 1/2. Cosine of the t of arctangent of 1 plus cosine of arc cosine of 1/2. You see that's easy? Cosine of arc cosine?
Yeah.
Oh, that piece 3, that's going to be just 1/2. And then sine of arctangent 1. So once again, just again, numbering them 1, piece 2, piece 3, piece 4. Your triangle, we're going to need a arc cosine of 1/2 triangle. Well, yeah, of 1/2 triangle for this piece. So piece 1 triangle. You don't really have to worry about quadrants with this. Cosine is adjacent over hypotenuse. Can you tell this is going to be the square root of 2 squared minus 1 squared? So 4 minus 1 is 3. That's going to be the square root of 3. Is this going too fast?
No, it's not.
Okay. So your sine is the square root of 3 over 2, opposite over hypotenuse. So piece 1 up there, if you remember them 1, piece 2, add piece 3, piece 4, we now have √3 over 2, and we have number 3, we have 1/2 there. So I filled in 2 of the pieces. I could fill them in up here, or I could fill them in down here. Are we ready for the arctangent triangle?
Yeah.
Piece 2, piece 4 triangle. All right, well, arctangent of 1, 1 over 1, y over x, opposite over adjacent. So can you tell this is going to be the square root of 1 squared, add 1 squared, that's the square root of 2?
Yeah.
I'm going to need the cosine and the sine of it. Cosine is going to be 1 over root 2, and the sine in piece 4, that's piece 2. And same thing in piece 4, the sine is 1 over root 2. So piece 2 is going to be times, see, 1 and 2 were multiplied, 3 and 4 were multiplied. So that's going to be 1 over root 2 times 1 over root 2. All right, again, a common denominator is 2 root 2. So 1 fraction with 2 root 2. And the top over here is root 3 times 1 is root 3. And over here you have plus 1. Now, it might like this answer and might want this rationalized, get that root 2 out of the bottom. I don't know. You want to see it rationalized just in case they want that form of it?
Sure.
Well, you need to multiply by root 2 over root 2. All right. So then you would have this in parentheses, root 3 add 1 times root 2. Bottom, you'd have 4. You see your root 2 times root 2 is a 2 times that 2 makes 4. I don't know what, what they'll want. You could distribute the root 2. I don't know what form they're going to want. You'd have a root 6 add root 2 over 4. Pick your form of the root 2 add root 6 add root 2 all over 4. Pick your form of the answer. You don't have to do all this gyrations. That's what drives you nuts. Sometimes they program want this answer and not this answer. It's how they programmed it. That's what drives me nuts about it.
Yeah.
Did you have any others or?
This one last one has to do with the sum and difference formula, and that'll be the last question I have.
All right.
This one says prove the identity.
Okay.
And it says sine of x plus y
Okay.
minus sine of x minus y.
Okay.
And that's to equal 2 cosine of x and then sine of y.
And sine of y?
Yeah.
Okay. All right. Well, this is going to be, these are all, when you see this kind of stuff, you're thinking back to page 581 and plugging in those kind of formulas for this and then watching your like terms and see if you can boil it down to this, because you will never turn this into this. All right. Can I just, I'm kind of running short on time. Can I just go ahead and write the formulas down?
Oh, yeah, that's fine.
All right. So a sine of something plus like that goes sine x cosine y add cosine x sine y. And then I'm going to go minus and then a big parentheses because again, you get two pieces. This minus sign is going to distribute. That's going to go sine x cosine y minus cosine x sine y equals this stuff. So I'm going to distribute that minus sign and get sine x cosine y plus cosine x sine y minus sine x cosine y add cosine x sine y equals. All right, so now what I'm doing is looking for like terms. And do you see sine x cosine y, sine x minus sine x cosine y there?
Yeah.
Those are going to cancel. and a cosine x sine y, add a cosine x sine y. That's going to be one of these plus one of these makes one there plus one there makes two of them, right?
Yeah.
One plus one of them is two of them, cosine x sine y. And on the other side, that's exactly what you have over there, 2 cosine x sine y. Only way I know how to do it.
There's this really small question here. I don't know if you'll be able to answer it quick enough. Would you be able to do it real quick, maybe?
Yeah, let's see what.
It says to use the addition and subtraction formula, but it's just 10 of 75.
Degrees.
Yeah.
Okay, then we'll figure this out. So you got to bust this up into circle values. Some are easier than others. Looks like this one would go 30 plus 45. There may be other ways to do it. You should get the same answer no matter how you bust it up, but 30 plus 45 should be 75, right?
Yeah.
All right, so then page 581, again, in the interest of time, I'll just go to it. A tangent of something plus something went tangent 30, like you're going to distribute it, add tangent 45. But on the bottom, you have 1 minus opposite sign, the product of them. So yeah, you can look back to page 581 and you can see that. Again, in the interest of time, at 30 degrees, your tangent is, I believe 1 over root, let's see. 30 degrees, you're at 1/2 in root 3 over 2. So your tangent, this is at 30 degrees, is 1/2 divided by 3 over 2. So that's 1/2 times 2 over root. It's 1 over root 3, which is root 3 over rational. It's root 3 over 3. Sorry, this is going too fast. Is root 3 over 3. Tangent 45 is 1. That's easy. Because at 45, you're at root 2 over 2 and root 2 over 2, both on x and y. So 1 minus root 3 over 3 and times 1. They probably want it rationalized. If you get a common denominator, you get 3 and 3 there. So you get, or simplified, root 3, add 3 all over 3. Down here, again, put a 3 there and a 3 there. You get 3 minus root 3 all over 3. You see how the 3's cancel?
Yeah.
Flipped it around and you'd wind up with root 3, add 3 over 3 minus root 3. I don't know if they want that form of it or what. I usually let people stop up here. Great. If they get this far, I'm thrilled. Yeah, I know you're trying to make that dumb program happy.
Right.
All right.
That was basically it. Thank you very much.
Okay, sure thing. Appreciate you coming out early on a Friday morning.
No problem. Have a great day.
Okay, same to you. Thank you.
No problem.